Putting up a pretty good fight though.
Huh?
You're like in second or third. I mean, you're top 5 still.
Me? I'm like trying to.
Go ahead and take notes on this. Today we're going to talk about something called direct variation, and the good news is it's really, really easy. So we won't have to spend a ton of time on this.
So it's easy for you.
It's super easy for me, so it's going to be easy for you. You're smarter than me anyway. Your brains are all young, fresh. I'm old.
You're right. Your face.
I forgot my keys yesterday. I left the house with no keys. You know,
That's what you get for having a smart card. You
Is
just
that
push
what
it
it
up
is?
the lock in your house.
Nope, got the garage door opener for that. I was locked out of the school though and my classroom, so I had to pound on the door till all the kids let me in and then go borrow Mr. Trimble's keys to get into the room. So, but that's okay. That's what you get. All right, so direct variation, you can write it in 2 different ways, and you've seen this before. Direct variation means either y equals some number times x every single time. So to make this make a little bit more sense, let's start with our old friend -2, -1, 0, 1, 2. Give me a number. 7. So if this was set up as a direct variation, then all I would need to do to find the y's is multiply each one of the x's by 7. So -2 would become -14. This would become -7, 0, 7, and 14. So what would be the equation for this? Right. And how do you usually write that? Instead of saying x times 7, you go 7x. Yes. So for this example here, y would equal 7x because you're multiplying by 7 every time. Okay? This thing right here is evidence that math teachers are really not as smart as you guys, because that number is called the constant of variation. And they use a K for that because constant starts with the letter K, right?
See.
Right.
Wait, why do you multiply by 7?
Because she said 7. What would you like to multiply by?
You can just do anything.
Yeah. Okay, so I'm just trying to get across to you that if you have some x's and the y's are just the x's multiplied by any number, and that's it, then that is an example of direct variation. Okay, so if I gave you this table right here, -2, -1, 0, 1, 2, and then let's go 4, 5, 6, 7, 8. What is being done to the x's to get the y's? Add 6. Is that an example of direct variation? No. It's by 6 each time, but since we're adding instead of multiplying, that is something different. Okay? Does that make sense, Maddie?
Yeah.
If you're multiplying every time, then it's constant then it's direct variation. And then another way that you can do it is if you look at these here, you'll notice that if instead you take the y's and divide them by the x's, you get the same number every time. -14 divided by -2 is 7. -7 divided by -1 is 7. What happened there? Did I do that wrong? No. I guess you can't do, yes, undefined, 0 with 0, yeah. So that one is...
They all go through 0.
Right, right. So that'll be there every time. Okay? So, you tell me direct variation, yes or no? And if so, what is my constant of variation?
Yes. Yes. Multiply by 2 each time.
Yes, multiply by 2 each time. So the equation would be y equals 2x. Okay, good. I told you this was easy, right?
Yeah. So we get
Okay, direct variation, yes or no?
No.
Oh, wait, no, never mind.
Tried to trick you because 1 times 4 is 4. 2 times 4 is 8. So if you're lazy, you stop there, you go, yeah, it works. But 3 times 4 is not 11. And it has to work for every single one. So then the simple answer there is no. And if the answer is no, you don't have to come up with an equation. You don't have to say what the constant of variation is because there isn't one. Okay? You can also show these, instead of using a table, you can use an equation or a function rule. Is that an example of direct variation?
No.
Why not?
Because this can
just can't.
It's not legal.
It's not what?
It's not legal.
If x is 1, what's y?
4.
Well, 7 times 1 is 7, but I need to solve that for y. So
7 divided by 3.
7 divided by 3, so I'm just going to leave that as 7/3. If x is 2, what is y? 14 over 3. If x is 3, what is y? 21 divided by 3. What am I multiplying the x's by each time to get the y? 7 divided by 3. 1 times 7/3 is 7/3. 2 times 7/3 is 14/3. And 3 times 7/3 is 21/3. So is it direct variation? Yes. What is the constant of variation? 7/3. And so the way you could have seen that with this thing right here, what can I do to this equation from the beginning to solve it for y? Janae with her sign language is telling me divide both sides by 3. Yeah, so then y equals 7x over 3, and then you can see a little bit more easily that that's the case. Okay? All right, how about that? Is that direct variation?
No.
Why not?
So you're adding.
Because of the plus, yeah, because there is a multiplication thing involved there, but after we do the multiplication, there's going to be addition as well. So that is a big fat no. All right, so now how about if I tell you that it is direct variation, and y equals 9 when x equals negative 15. You tell me what y would equal when x equals 21. So now you know, I'm telling you ahead of time, it already is direct variation. You know that as a fact. Can you tell me what y would equal when x is 21?
Can you set it up as a proportion?
You certainly can set it up as a proportion. Yeah, what proportion would you use for that?
9 over y equals -15 over 21.
Okay, awesome. And then what do you do to solve that proportion? Okay, so we're going to multiply these guys together and get 189.
And then divide.
I could, yeah, we could reduce this a little bit. Yeah, that would make the math easier, but that's okay. And then divide it by negative 15. And what do you get for that? 12.6, okay? Divide by negative 15, so then y would equal negative 12.6. All right? So, yeah, excellent strategy because proportions are really easy to solve. So if you know that it's a direct variation already, if they tell you that, you can set up a simple
Would
proportion.
it always be y over y and x over x if we go like
You can go sideways if you want, as long as you go the same direction. So you would get the same answer if you went x over y and x over y. Where you get into trouble is if you try and crisscross. If you go this x over this y, and not, then things get screwed up. Okay, you guys got it?
Yeah. Homework.
Oh, you're so excited for homework.
Oh, yeah.
So
Love to get out of there.
same time as yesterday.
Holy cow, that many pages.
Hey, your recording's still on.
That is a good question. A 22.
So much homework.